Okay, today's lesson is on frictional forces. This is just a review from Physics 11, so I'm not going to go into great detail here, but we will just do a brief review of the topic as we are going to need to be able to use frictional forces to do more work in the dynamics unit. Okay, when an object moves or attempts to move along the surface, there's also a component of the force that is parallel to the surface. This parallel force component is called the frictional force. So when two surfaces are in contact together, even though the two surfaces can appear to be very smooth, um, there's always some roughness between the surfaces. Okay, so there are some grooves and hollows inside the surface, some hollows and some grooves. And it's when those grooves and hollows interact with each other, there's an electrostatic force that creates an attraction between the two surfaces, and the two surfaces sort of gel together, and that causes a frictional force. If F applied, Fa is small, it does not move the object because the static frictional force exactly cancels out the applied force. The forces are equal but in opposite direction. If the applied force increases, it does not move because the static frictional force still increases and exactly cancels out the applied force. The forces are equal but in opposite direction. So basically what that's saying is that the static frictional force keeps increasing as you push harder on an object. It matches that force until you reach some maximum. And then when you reach the maximum static frictional force, once you reach that point, that is when the object will start to move. Okay, so you can see here in this diagram that the force applied is exactly equal to the static frictional force, and as a result, there's no movement. So eventually, as the applied force continues to increase, the block finally breaks away and begins to slide. The force just prior to the breakaway represents the maximum static frictional force the table can exert on the block. So as you keep increasing the force, the static frictional force reaches some maximum, and then it can't increase any more than that. And so at that point, the object is going to just begin to move. Any applied force greater than Fs, F static friction, will result in a net force causing an acceleration in that direction. The magnitude of the static frictional force between any pair of dry surfaces has two characteristics. It's independent of the surface area in contact, so surface area does not affect the static frictional force. And that might seem counterintuitive because you would assume that a greater surface area causes more friction, but that's not the case because a greater surface area reduces the pressure between two surfaces, which nullifies the effect of a greater surface area. Magnitude is proportional to the magnitude of the normal force, how hard the two surfaces are pressed together. So the static frictional force is exactly equal to two factors: the coefficient of friction, US, and the normal force, the force that pushes the two surfaces together. Once two objects begin to slide past each other, kinetic friction comes into play as an opposing force. It also has four characteristics. It's independent of the surface area. It's independent of the speed of movement, so it does not get affected by how fast two objects are moving across each other. Kinetic frictional force is not dependent on speed, and it's directly proportional to the magnitude of the normal force. So the kinetic frictional force, I'm just going to get my pen here, is equal to the kinetic coefficient of friction, mu k, times the normal force, Fn. And mu k is usually lower, is almost always lower than mu s, the static coefficient of friction. So here's a sample problem. A wooden block of mass 4 kilograms is being pulled by a 12 Newton force to the right. The coefficient of kinetic friction is 0.2. Calculate the force of friction acting on the block, the net force acting on the block, and the acceleration of the block. Construct a diagram and label all the forces acting on your block in your diagram. You should have 4 forces. So in this case, you can construct a diagram. So you have a block and you have F applied, and you have F friction. Okay, you also have Fn, and you have Fg. Now notice that the F applied is slightly greater than F friction, because in this case the block is accelerating to the right, and so your F applied is going to be slightly greater than F friction. So we can calculate the force of friction on the block. You can pause the video if I move too quickly and you need to write the notes. So F friction is just equal to mu k times F normal, and that's 7.84 newtons. And then we can calculate F net. F net is equal to F applied minus F friction. The general formula for F net is sum of all forces. This symbol here means sum. And that usually what that means is you're adding all the forces together. So F applied plus F friction. But in this case, since F friction is negative, you're subtracting the forces. And it becomes 4.16 newtons. And then we can calculate the acceleration using Newton's second law. F net equals ma. And substituting for the values, we get a equals 1.04 meters per second squared. And that concludes the presentation, and there's a worksheet with some questions to follow. Thank you.